if you need, that's where the slides are at. It's a short link to the GitHub. You're welcome to clone the GitHub repo or to just follow along, have it side by side as slides, because the most effective way to learn is going to be to code along with us, not as much to copy and paste. But, you know, whatever you prefer. Should we introduce? Okay, so hey everyone. I'm Hannah. I'm a grad student in computer science, especially visualization. I'm one of the Matplotlib contributors, devs, whatever. And I'll be co-teaching this with Thomas.
I'm Tom Caswell. I'm a staff scientist at Brookhaven National Lab, and I'm currently the lead Matplotlib developer.
Hi, I'm Kimberly Orr. Last year I was a John Hunter Matplotlib summer fellow, and I'm helping out here. So.
Hi everyone. So let's do some level setting. This tutorial is intended to be a beginner's tutorial. It is part of the beginner's track at SciPy. So if we are going too fast for you, sticky flag up. Tell us on the Slack, let us know, right? This is geared towards starter level. If we're going too slow for you, we did try to, as much as possible, set up the tutorial so that there's lots to do in the notebooks. And I think there are like 10 of them. So, you know, feel free to go ahead, you know, start asking some questions. We'll just try to allocate a good chunk of time at the end for questions, because we know a lot of you have pressing, like, how do I do just the one plot I need to do my thing? So we will allocate for that. The other thing is also, if you're like ahead and you know the things right, be a teacher. Ask the person next to you if they need something, because the best way to learn, bar none, is explaining things to other people. Me and Tom learned a lot about documentation just doing this tutorial. Okay, so Matplotlib, right? What is this? How many of you are like vaguely aware that Matplotlib is a thing you should know? Score, we're already ahead. Okay, Matplotlib is the Python visualization library. It's kind of the, I don't know, say granddaddy of them all, but it's one of the big major ones. It is most widely used as, it started out as part of cognitive neuro PhD, so by John Hunter. So it's very much coming from the scientific framework and from the scientific viewpoint, and it's used a lot in scientific visualization. Because of this, right, Matplotlib started, if you need a paper, if you need static plots, this is your go-to library, possibly your only choice in Python. And it also can do a lot of interactive dashboards, GUIs, whiz-bangs, because, hey, scientists need dashboards. So the tutorial is going to start with the basics. Our goal here, like, you all aren't going to learn all of Matplotlib. We don't know all of Matplotlib. We're not quite convinced anybody knows all of Matplotlib. What our goal here is to teach you enough of the vocabulary of Matplotlib and the core concepts so that when you Google and when you ask us on Gitter and Slack and Twitter and Stack Overflow and all the things, you can start kind of learning the right language to use to get your answers faster. The other goal we have here is that you start getting a feel for kind of the features, right? What can this visualization library do? Like if I'm trying to figure out, hey, I need to make this plot, like, is this even within the capabilities? The answer is probably yes, because Matplotlib is really, really fully featured. But we want to kind of, again, start getting you a sense of like, what boundaries can I push? What can I do here? So, by the way, this is the logo. It was, of course, made with Matplotlib. We support all sorts of coordinate systems. Okay. Again, signpost, if you ever are losing track of the slides, that's where they are. We do full notebooks. So, step one. I want you all to kind of start looking at like, what can Matplotlib do? I want you all to go to the gallery, that's the short link, find a visualization that speaks to you. anything in the gallery, like what speaks to you? What do you have a burning desire to make? What are you like, how in the world did they do that? So I want you to grab one of those. Doesn't have to quite be the gallery, right? If you like see a Matplotlib figure in the wild or one at work that you're also really interested in, that too. I want you to turn to your neighbor and tell them what it is about that image that appeals to you or that you'd like to know more about. And then I want you all to post the images to Slack. And we'll give you 3 minutes. And also, if you're still having like install issues, raise a flag. Let us know. Catch it the earlier, the better. And if your computer at this point has decided to just conk out and give up, we have options. We always have options. If you click through our GitHub, you will find a link to Binder. And Binder is an interactive environment. It's going to take about 5-10 minutes to load. So like I would start it now, but that's kind of a backup. While I'm at it, let me pull the room actually, also while I'm at it. How many of you all are scientists or science adjacent? How many of you all are scientists in a data science context? Marketing analytics people? Grad students in a field I didn't mention? Anything else? Teacher, that works. All for it. Okay. Thank you, Colleen. Very much sympathize with you. Explaining to people in their own language is like the big thing we're doing with visualization because people, they're happier if you show them pictures, right? Usually it's easier. We don't need a mile of words. So that's what we're trying to do with this tutorial. Be like, how do you make those things? Right? How do we make all of our basic plots, our line plot, our bar plot, our pie chart, heat maps? We definitely have a whole thing on images, right? Because I can do this, or I can do 3 or 4 paragraphs of text. So we're going to talk about this, right? So I have a question for you, though. Is that image good enough to show in a corporate report? Vaguely, right? So one of the other things we're trying to get at through this tutorial is also to kind of start talking through, like, how do we customize those images, make them kind of more in line with your company's style, make them more in line with your lab style, get all our labels in, our ticks in, within reason. Oh, thank y'all. So let's. Okay, so like we were saying, as this tutorial progresses, you might need help. Totally fine, totally normal. It's a novice tutorial. Like, honestly, even if it was an advanced tutorial, everyone needs help all the time. So, Tom, Kimberly, me, if I'm not up here with the mic, we're all eager, ready to help, and Maddie is also here, right? You guys are blessed with all the people. Make use of them. Easiest way is going to be either post on the Slack, and like with your seat number coordinate system so we can vaguely find you, or put up a sticky flag. Right? Everyone has their sticky? Okay. Put your sticky on your laptop just so we know who still needs a sticky. You're welcome to sit there for now. Yeah, because I know, trying to hold your hand up for like the whole extended period of time, not very fun. Are there extra stickies floating around? She has a sticky. Okay, stickies down, unless you need a fix. Score. Stickies down. Thank you. Don't worry, I will totally leave a sticky up like the entire time for tutorials. It's all good. Okay, so great, right? We're in the tutorial, you have him, her, me, him. What happens afterwards, right? Because you can't quite take us home with you. You kind of can though. Here's how. After the tutorial, we have the docs, right? We have written some of the docs. Other people who are better writers have written some of the docs. There's a lot of docs, possibly too many docs. This tutorial was an adventure in like, oh, we have a doc for that. So we have the docs. Like I said, they can be a little bit weedy. So if the docs prove a little bit too much, you can also ask us like, hey, where in the docs would be a good place to start? How do you do that? We have mailing lists. We have very active, very eager users on our mailing list. We have Matplotlib users, which is the users mailing list. That's the like, hey, I need help. Matplotlib announcements, where that's where we just be like, new features, doc internships, all the things. And we have development, which is like, I need a new feature. Can this go in? Or you're like, this thing is broken and can you change it? And here's how. So that's the mailing list. If you're not an email person, the Twitter account is man, woman, person. So that's a place to ask. So is the Gitter chat. Someone's always on there, eager to run and help. If someone's like rude to you, drop us an email. We have matplotlib@numfocus.org or DM or something, and we'll try to deal with it. We aim, we strive, we want to be friendly. Okay. Ugh. So what do we need for this tutorial? This is what happens when you use Rise and Jupyter Notebooks. Of course you don't render your slides, but you think they're rendered. Oh, and that's the live Markdown preview, which is why you can see the Markdown and the regular. Great for editing, bad we need to double check that things worked. So, which libraries do you need? We need Matplotlib, of course. Pandas to do, because we're like, let's do real data, right? So the easiest way to do real data is to use the Pandas data analysis library to do manipulation. How many of y'all are going to the Pandas tutorial next? Score. So this is the baby light, we're going to gloss over a lot of things version. And there you'll get all the real juicy bits. So we have Pandas. And how many of you all went to the NumPy tutorial this morning? Yesterday. Score. So Pandas is the spreadsheet library, NumPy is the matrix library. And we'll be using NumPy for like some mathy things. So, versions. Anyone have a guess why we want to ask for version, why we're going to print that versions here right at the top? Yeah?
Compatibility, right? Make sure that we are running the right versions consistently.
Kinda. Anyone else? Close to compatibility. It's that slight differences in versions can have slight differences in functionality. And so like, most of it won't matter. But if you're getting a figure and your figure looks slightly different than the figure I have on the board, 90% of the time it's like a version-y thing. Like the difference between the image I had in the install and everyone else's image that they got in the install was my versions of NumPy and Python and Matplotlib played together such that I got the smooth curve and everyone else's version played together such that the nans blew things up. Right? So we're going to do the version at the top just so we know, are we on the same page? If not, like, do I just need to keep that pinned when things look a little bit weird? So here we're going to use the f-strings to print the versions. F-strings is just Python pretty string formatting. Good. Hand mic doesn't work for code. We need to, okay, so what I want from you all, also, yell at me if I'm not near a mic and you can't hear. I will try my hardest, but as you see, I like to move. So just like, reel me back. So, step 1, type this all in to check that we have. Or run the notebooks. Yep.
Does it not care about single quote or double quote? Because I know one
Oh.
time you have single quote, next screen you have double quote.
It doesn't. The official difference is like byte string versus ASCII character string, but they changed it.
No, the
It's
single
a-
double quote, Python's agnostic to,
But-
and you can switch depending on if you want to nest. So if you want to put your single quotes in your text, you double quotes outside. If you want double quotes inside, you single quotes
I
outside.
thought there was they
That's the
changed
key.
it.
That's the kernel that leads it.
That I know, but I thought
Nope.
they used to. Okay. 90% of the time, the difference here is going to be which one of us wrote it or how tired we were. Yeah. Okay, so I'm running Matplotlib 3.1, which is our newest release. Is that newest release?
3.1.
Yep.
3.1 came out last week. But
Yeah, 3.1.
it's major.
Yeah. Panda still doesn't have a 1. And Numpy. How many of you all are basically here? Basically running these versions? Okay, good enough. Okay, everyone here running Python 3 at least?
And you're running Python 3.
Okay. Yeah, there's a link in the getter. And if you need it, the link is also here. So, let me, here. Okay. Okay. Okay, so these slides are a Vise. Okay, these slides are the notebook. I'm just using the Vise plugin to turn them into slides. So if you're seeing a notebook and you're like, where are the slides? These are the slides. Yeah, I just bits of it are skipped, which is that I'm not turning that into a slide. It just froze. And then the bits of here that slide are what you're going to see as slides. The reasoning behind this is mostly because I think those words are unreadable, on a screen this big. What? So, yeah, so there's a GitHub. Everyone's got Matplotlib or something equivalent kind of set. So what are we doing here, right? For most of this, we're going to be working with the Titanic data set. And the deal with the Titanic data set is it's a set of its ship logs. So it's kind of a passenger manifest. What kind of we care about is, right, it's got names, it's got who survived, it's got their age, how many siblings, parents, children, it's got kind of all this information. Because this is what someone said on the Slack. This is what someone said on the Slack, right? Why do we do data visualization? Because we need to tell people about what we're trying to do, right? Trying to write reports. So here we're going to try to make a report based on the Titanic passenger logs. And the question I'm usually interested here is can I cut up the demographics on who lived and died on the Titanic? So for the most of this, we're going to do a bit.ly link, so you don't have to worry about file path stuff. But if you want a local copy to open up in Excel or whatever, this is the link. Or if your internet's being cranky. Okay, so step one, and this is a little bit of pandas, is we're going to read in our data. So we want to read in our data into a data, what's called a data frame object. So right now, DF stores our spreadsheet, basically. And we have these columns in our spreadsheet. This is dataframe.columns. So this is how we can like access the different attributes in our data frame, so we can like plot things. Okay, so this is a modification of the code I gave everyone. Right now, we just want to make a like just one last install check, because let's get all the install checks done. Gonna use the inline. Inline is what's called the setting a backend, which is that's the thing that actually takes your code and translates it into pixels on the screen. Here, the inline backend is the one that tells Jupyter, hey, Jupyter, show me my notebook, show me my pictures. We're gonna make a figure and an axis, and we'll talk about this later, what all that means. And then we're gonna plot the data. Here, we're gonna plot the age column with dots, very little dots. So if you don't have something that looks kind of like this, at this point, please put up your flag. And also pause, yeah. Okay. Okay, I'm just going to give it another minute. That's good. Okay. So why are we using notebooks, right? Because we could just as easily do this, or not quite as easily. We could have also done this as just like raw Python, right? Like load up a Python, a text file, run a script. So why are we using Jupyter Notebooks? A lot of it is because it has this inline image capability, so we can like very quickly see what we're doing. And the other reason is because Jupyter Notebooks have a lot of like really newbie user-friendly kind of stuff we can exploit when we need to ask questions. One of the ones we really like is the question mark. So when we're like, hey, I want to use this new thing like plot, how do I have a question? Like, what does plot take? Like, what arguments can I pass to plot? What will it let me do? So I type the name of the function, and I do a question mark. And it pops up with, this is the documentation for the method. So here it says plot can take an X and a Y, it makes a plot. So anytime you're starting to see a new like unfamiliar plotting method, the dot plot, the question mark is kind of the way to ask it, interrogate it, like, what should I be doing here? Okay. So that's so at this point in the tutorial, y'all should have a working install of Matplotlib and made this figure. If you're not on that page, please put up a flag. Okay. So let's pull up the next notebook. Files, the overview. And what we'll be doing now with the overview is, okay, let me go back a second. My notebooks look like this. You will see them presented as this, because like I was saying, I take the notebooks and I turn them into slides using the Rise plugin. So if you see the notebooks on GitHub or NVIDIA or Launcher, they are the exact same thing I'm showing here, without the flows. Okay, so what we want to do now is the goal of this next section this notebook is we want to start getting around, wrapping our heads around like the terminology of Matplotlib. You know, like, right, what, can y'all tell me, what are the components of a graph? Axes, title, coordinates, legends, shape, the actual data, markers. Do you all know what they mean by markers? What? Dots. Are markers always dots? What else can markers be? Crosses, shapes, yeah. Lines. Do you all know what axes mean when they say the axes? Does Excel also refer to it as axes? Does? Ah. What about ggplot? None of you. Okay. That's fine. But so the question I'm having here is sort of like, okay, so we have sort of like with visualization, right? We have this semi-shared language of like markers are the dots we put on a scatter plot or on a line plot. They're dots to mark points, hence markers. Axes are the X and the Y. What else, right? We have the titles. But the question, but the question is like, we know how we refer to it naturally, right? But if I was going to try to, but are you sure like everyone else is naming things the same way? And so the thing we need to do, right, for Matplotlib to understand it, customize it, make out pretty pictures, is to understand how Matplotlib names things. So there's this great figure called Anatomy of Matplotlib that describes how Matplotlib names things. This is kind of small here, so you might want to pull it up on your computers. And the first thing you need to know, right, is a plotting library, it has to take anything you want and put it to screen. If it has to put it to screen, there has to be some code underneath that puts it to the screen, which means that there's code controlling it. So when we talk about our image, in Matplotlib, we're really talking about this terminology here. So, like you were saying, like in every other plotting library, the X, which is the horizontal, is an axis. AXIS. The Y, vertical, is an axis. AXIS. The whole image is an axis. AXES. Yes, this is a pain. But like when this is a thing we need to just like pin in our heads, because this is how you will see throughout the code. We refer to axes. Axes have axes. Axes have axes. And also because our main data plot object is the axis object. Like that is the thing we control, that is the thing we will plot on. Like here, right, we will set our labels on the axes. We add lines to the axis, we add dots to the axes. We set a title. So everything is centered around this axis object, the AXES object. And so the first thing we're going to do, right, to make our axis, because we're going to make a figure, not quite this one, but we're going to try to make ourselves a pretty customized figure, is we need to import. We need to grab Matplotlib and we need to grab Jupyter and we need to just make the image. So if you have a high definition image, a high definition screen, you need to do this config inline backend figure format retina. You don't need to do it, it's just going to look fuzzy otherwise. So put in that line of code to make everything pop. Then you're going to do Matplotlib inline to draw, again, does anyone remember why we do Matplotlib inline? Exactly, to show our image in the notebook. And then we're going to import Matplotlib, and we're going to import NumPy, right? Because we need our libraries. And yes, every new notebook, we have to re-import everything again. So what is this backend thing? The backend is, like I was saying, the backend is how we go from Python to pixels. We here will use inline. So and we asked Matplotlib here, what backend do we have? Backend inline. If you're not writing in a notebook and you're not using inline, you can use a different backend. And there are a ton, right? There's Cairo and Qt and MPL Cairo. And if you want interactive web-based stuff, there's an HTML canvas out of Pyodide that's doing some like new shiny sparkly things. So the job of the backend is, in some ways, it's not only that it takes you from Python to Pixel, it also controls like how interactive can I get here, how static, what file formats do I support, because different backends will support different formats, and Matplotlib will generally render to almost any image type under the sun if you use the right formatters, right backends. Okay, so it's not so important that you run this code right now, but often if you're trying to debug Matplotlib, one of the first things we'll ask you to do is to tell us what the backend is. Okay. So we all have Matplotlib loaded, we all have a backend. Let's make things, right? That's why we're here, let's make things. Step one, when you are drawing something, what is the first thing you need? A surface, right? So in Matplotlib, that surface, that drawing surface is called the figure. The first thing we need to make is a figure, and that is the thing we are going to draw on. So there are many ways to do it. The classic is to use the plot.figure. And of course, it just doesn't show me anything, because this thing I decided, I'm not wasting the paper until you actually start drawing. So we're going to start drawing, right? We're not going to just be like, I want a paper. I'm going to be like, I'm a paper, and I'm going to put my pen to it and start like scrawling. We don't use plot.figure for that. We use a helper method called plot.subplots. And what plot.subplots does is it gives us the figure, and then it also gives us an axis on it. And what was an axis? What is the job of an axis? What? I heard someone who was like on the right track here. Job of the axis? Exactly. It's the coordinates, it's the scales. It is the thing we actually plot on. Your pie chart, your bar chart, your heat map, all of those are axes. All of those get plotted on axes. Because we can plot multiple scatters and multiple pie charts on one axis. But the axis, the axis is that visual. Like that is the chart you're handing to somebody. So you can have multiple charts on one page, right? So that's the job of subplots here, is to be like, here by default, I only want one image, one chart on my page. But sometimes I can be like, I want two charts on my page, right? I want a bar chart and I want the pie chart. I can want three. I want the bar chart, the pie chart, the heat map. I want 10, right? Because I want small multiples. Every day I want a heat map. So the job of plot.subplots is like, I'm going to help you. Instead of making you do all these little pieces manually, I'm going to be a factory. I'm going to give you a figure. I'm going to give you one axis, three axes, however many you tell me. Here, we're going to just make one. Also, if I'm speaking too fast, put up a sticky. Yeah. Yeah. Okay. So, plot.subplots. See, it makes a figure, and it makes the axes. And how do we know it's an axis? What here's the dead giveaway that we have an axis? Do you think? Exactly, tick marks. Because we have the X and we have the Y tick marks. So we know we have an axis. Because traditionally, right, an axis has the axis, the X-axis, the Y-axis. We also can do 3D, X, Y, Z, but that's a little bit out of scope here. So, is this useful to us yet? technically, we can start plotting on this, but that's the pipeline interface that we will not cover in this tutorial because you shouldn't use it. So what we're going to do is we're going to use the object-oriented interface. To do the object-oriented interface in Matplotlib, what do you think I need to do to plot.subplot so that I can use the objects? Plot.subplot returns two objects, a figure object and an axis or a collection of axis objects. Exactly. Yolvak. Assignment. We're going to assign a figure and axis to our plot.subplots so that we can have those objects so that we can work on them and modify them. So, here, fig ax equals plot.subplots. And it's still going to show display in line because that's how this all works. Magic, no? So, we have an axis now. Now what do we want to do? Because this is kind of what? Can you hand in a plot like this and be like, I'm done? Yeah. Sometimes. Yeah. But we really need to now just plot something on here. So, let's add data. Why not? The first thing we're going to plot on here, what do you think? I'm going to make you all plot now. Now that we know what we're doing, vaguely? What? Okay, first thing we're going to plot now is the same thing we've been plotting till now. Open our data, yet again, because remember, every new notebook, we have to grab data. Also, tell me if I'm not giving you enough time to copy code. Okay? Okay. Okay. So, read in our data. And now we're going to make our subplot. And on our axis, right, that empty sheet of paper, we're going to make a plot. The dot plot method is the simple line plot. It is also a scatter plot. But here we're going to use it. The good part about scattered, like the reason we use it is that the plot is that here is that plot is a scatter plot that we don't need an X for. If we pass in plot and we pass in Y, it'll do the X's for us. Because here we're just doing a cumulative distribution function, basically. We're just plotting the ages sorted. So on our axes, we're going to sort our ages using NumPy to clean up the nans. We're going to give a marker of 0, so it's going to be circles, so that looks like a scatter, and we're going to make them tiny because there's a lot of data here. Any questions about, is there anything in this code that looks like, why is this there, and what does it mean? Yeah. Great question. What in the world is that underscore about? So the thing is, the plot methods and all the Matplotlib methods, they will, and this is not just them, because a Jupyter notebook is a Python interpreter. It runs execute line by line. So what'll happen is it'll print what's called the object representation. So if I do this, you get this kind of string here, lines 2D. So the job of if we assign this to a variable, like that, then it suppresses the print. And by convention, we use the underscore when we don't care about the thing returned. So basically, this is a convention to suppress prints in our case. And when you see it in other people's code, that underscore means we don't care about what this function returns. But we want to assign it for reasons. You'll see this construction a lot also in for loops.
Is there a place to find what the valid markers are?
Yeah, we're going to go through that. That is notebook 2. Yeah. But also the Matplotlib docs. Yeah. Okay. Making our figure? So what are we plotting? What are we plotting here? Or better yet, what is this thing missing? Labels, units, right? We can get the units from the labels. So step one, let's label. Okay. The Matplotlib labeling methods are basically all set underscore the label we need. Set Y label, set X label, set title. So here we're going to set X6 label, set Y tick labels, set underscore. So here we're going to set the Y label. And the Y label is, was it on the screen? Ages. Yep. And the X label and the title is the Titanic. And who can guess how I can set the X label here?
Set underscore X label.
Set underscore equals? Exactly. And it happens to be its passenger. Yeah. Yeah.
Why do we ask you line one again? So when we have asked you, why do we always have to ask you?
Oh, the big act plot dot subtitles?
You did that, so why do you? I tried it. If I comment it out, it won't work.
Yeah.
So the way the inline backend works is you create a figure and axis, and when it displays it, it then destroys that figure and axis object, and it won't display it again. Every time you want a new figure to appear, you have to call subplot.
The image only exists for the cell in which you created it.
So that's in Jupyter.
Yeah. Oh. No, if you write it, no.
So if you're using like one of the interactive coding backends, the figure and axis will persist for through your entire session. This is an artifact of using the inline backend. And in some of the later notebooks, we'll use interactive backends for the notebook, and those will persist between cells and you can reuse.
Yeah, and if you're basically if you're writing a script, none of this is an issue because in the script everything gets run together. What? Oh, yeah.
Why should we put the FIGP in front of that line? Actually, we didn't define what the fig is.
This?
Yeah.
The reason we do it, honestly, I get what you mean, because we're not actually using it here. Right? You're saying, why didn't we just do this? Usually it's honestly because we often want the fig because later we'll use it. Like to save out, you need,
But actually, we didn't define what the fig means.
what,
That fig means. Actually, in MATLAB or in Fortran or any other language, we have to define any
oh, I know what you mean. So the plot.subplots is a factory method that returns both the figure and the axis. So the plot.subplot creates that figure for us. We don't need to ID it. Like you're saying in MATLAB, we need to do fig parentheses 1, right? Or fig parentheses 2. Python, we don't need to do that. What will happen is if we want one, because in Python, because that's an artifact of using this, in MATLAB, using the state machine, the state version, right? Because in MATLAB, you need to do plot.figure1 because you're not assigning it to anything. So here, because we're assigning the output of plot.subplots to the figure object, it's stored in that figure. So that variable name lets us keep track of the figures because the variable names are arbitrary. If I had multiple figures in this notebook, I would say, hey, this is fig 1. And then I'd make another, then I'd call this code again. And that's how I would create my second figure. So Python, that was the PyPlot interface that I was like, we're not going to do, but that's the one that looks exactly like MATLAB, and like MATLAB, you need to do the you can do the plot.figure 1, 2 count. Yeah. Okay. So made our figure, and we have labels now. right? I've got ages, I've got passenger, I've got a title. Yep. Yep.
Include symbols in the label of the axis.
How do I include?
We include symbols, between the symbols. Like for instance, passenger is mentioned micro number of people. I want to put it like
Oh, so if you want LaTeX, you can do, and you might not even this, but you do $sign. I'm gonna just do theta because that's what I know at the moment. And it'll render the symbol. So yeah, it fully supports LaTeX. I don't even know if you need the R actually.
It's safer.
Yeah.
Actually, no, you need the R because Python's gotten stricter about escape characters. So like, Python, if you don't have the R, Python would take the slash T
Yeah.
into a tab,
Yeah.
which is definitely not what you want.
Yeah, so if you do an R, you'll get, yeah. And since at least 3, Matplotlib supports a full Unicode character set. So you can do like your labels in Arabic, Cyrillic, Hebrew, whatever. What? Okay. Actually, more of you are awake than I thought. So, do we have this figure? All good? Ready to do more? Okay. So, we have figure, we've made up the passengers. Let's mess up the y-axis, right? Because is there any reason why our ages are 0, 10, 20, 30? Do we ever think about ages as human beings in 0, 10, 20? What? No, right? What's the problem with 10 to 20-year-old? Vast difference, right? How many of you know or have 10-year-olds? How many of you know and have 20-year-olds? Are they the same? Only sometimes, right? So what we're going to do first is we're going to change our y-axis to a different scale that kind of reflects some kind of binning that we're doing. Now, yes, in real life, you probably wouldn't set your axis scale to do your binning because that's what other things are for. But we wanted to show, like, how do you change things up? So we're going to do demographics. We're going to now break up our y-axis into the US Census demographics. I chose the census demographics because it was the easiest, most readily available age binning. So we're going to set a scale according to this. The titles come from like the Bureau of Labor Statistics, how they classify the different demographics. What was I going to say? Yeah. So ticks come in, yeah. So the thing you need to know about ticks is we have 2 pieces to them, right? We have the actual ticks, the locations of the marks, and then we have the labels, right? Because our labels don't need to be the actual locations of the mark. How many of y'all have this, where you have data, where you plot the data, the Y, but then you need to name it something completely different? Right, happens a lot, especially if you're dealing with categories, but also just like your data is 0 to 1, but you're really multiplying out in your head. So the way we control this in Matplotlib is we have the ticks, the locations, and we won't really get into it here, but if you need to make it fancier, there's a whole locators library. So the locators are how we control the ticks fully. We can set it to automatically set ticks based on some rules. We can have it set, give me the ticks. I'm going to give you the list of where I want my ticks. Give me those ticks. We can have it like give us multipliers. We can have it do like dates. So the locators are how we put our marks in the places we want. Then we need, and that's location, right? Ticks, two pieces. What are our 2 pieces? One is location. What is the second part of our ticks? The names, the labels. So the way we control labeling is what's called the formatters. And again, we can manually pass in our string of labels, Or if we have like some kind of rule that we want to apply to the ticks we already have, we can use what are called formatters. And so the formatters let us do all of this like fancy magic on our ticks. So like pull every second, convert my date using this pull from my data set and apply here. So those are the formatters. Here, what we're doing right now is we're under the hood using the locators and the formatters, but we're going to use the helper methods to they'll do all the machinery. We're just going to be like, I want these ticks in this location, and I want them labeled this way. So this code here does the first bit, the location, the locator. And here, I'm telling it specifically, hey, set my ticks at 15, 25, 55, and 64. That's when I want to see my marks. Okay? So I'm not going to run this code. First person to get this working, post to Slack. Okay. What do you see when you get this working? 4 ticks. Where are our 4 ticks? Okay. So let's go down this line by line again just to kind of reinforce this. Right? What's happening on that first line? Creating the plot, right? Creating the figure, creating our piece of paper, and creating our XY that we're going to draw on. What's that second line? Data, right? So the second line is going to be data, right? Where we're going to plot the actual X and Y points here. In here, we only have the Y, which is the ages. So we're plotting the assorted ages. We're marking them with a 0, setting the size of 1. What's happening on the third line? So on the third line, what's going on here? Yeah, exactly. We're labeling the y-axis. Third line gives us the y-axis, and fourth line? Setting the ticks. Right? And here's the beauty of Jupyter Notebook. Like, this is why we use it. First line. Second line. Third line. Fourth line. See, age is now up here. And fifth line. Now the ticks are different. The reason we're using, this is the flexibility of the Jupyter Notebook environment, is that we can see line by line how our code changes our plot without having to run the whole thing from scratch. And we're going to see how, like, in Matplotlib, we just keep, like, layering things on top of our plot, attaching it. So this can be a little bit not great to see. So I'm going to right-click. Okay. Magic. If you need your image to be a little bigger, you right-click on it. If I can find, yeah, we right-click on it, and then it'll blow up. Okay. Okay. And so now we have this, and now let's do the last bit, right? So we did the location. Now what do we want to do on top of the location? Exactly, the labeling, right? Because ticks are great, but these are categories. So we want to tell people, like, here are the categories we're thinking of here. So we do. We use set tick labels. So remember, we broke down. And now we pass in a list. To Y ticks, we pass in a list of the locations. And now to tick labels, we pass in the list of labels. So, and it's a little bit hard to see, but see now, seniors, adults, youth, children. So the tick labels can be any, like, for labeling, we support any of the text that we would support anywhere else in Matplotlib. Like if your font can do it, Matplotlib can do it. Within reason. Okay. So I want you all to do an exercise. I want you all now to make your own plot. We've been doing this with the ages. So now, and I'll give you all about, let's say till 9:30, let's make a plot. I want you to plot the fares. Give me a cumulative distribution of the fares. I want you to make the cumulative distribution of the fares. I want you to label everything, the X, the Y, the title. And I want you to label the X based on the fare classes we had here. Right, so kind of, I want to see the boundaries, right? How many people here paid for third class? How many people were in second class, first class berth, and for first class suite? Okay, so what is that figure going to look like here? Right, we're going to make that. Now, what comes next? AX, that's the title, okay. What's our title? I can't spell, so okay. Okay. How am I plotting the fare? What do I got here? Fare. Okay. What else do I need? Okay, what else do I need? What comes next? What? AX dot what? Okay. Okay. So I created the figure in the axis using plot.subplots. I set the title using the setTitle method. I made the plot using the ax.plot method. And again, this plot is a scatter plot, which I'm saying by using the marker equals 0. I'm setting the fare using the set y label because the fare is on the y-axis. I'm setting the x-axis as people because the x data really is passengers. We've got one, because we have one record of fare for each person. What comes next? Yeah, I'm going to set the ticks. The locations or the labels? Anybody know? Exactly. X tick locks. Wait, X6, yeah. So there are 3 what? 3, 12, 8, 7. Y ticks. Nope, I think I was a mistake, not you. Okay, and what's the last thing I need? Exactly. Y tick labels here, and labels are, third, second, first B, and first A, first S. Okay, and what in the world? What's it? Oh, yeah, -1 is not going to actually work. Okay. Okay. I want to see something because this is being. Mine still has the line. Oh. Your luck. Great. But it still has the line. That's the thing that confuses me, because the line is supposed to go away. Okay. If you actually need the line to go away, I thought none worked. Okay. If you need it to work, and it's being cranky. Okay, what problem are we seeing here? Like, what is the, like, ouch on this plot? Squished. So one of the things we can do is we can just pitch it to log scale, right? It's like ax.set scale. ax.set y scale and log. Yep. So it'll set stuff to a log scale. Now the problem is we have to relabel, because our labels are not in log scale. What? The tick labels are gone.
Yeah, okay, it's not like we always have to take labels. Do that first.
Yeah. Yep. It puts it in the right place. Yeah. So, yeah. So if you need the sets, if you're like, right, we did this and we were like, this is a disaster. Right, you can't read anything. And when we see this, we're just like, this probably means it's in a different scale. So what we can do is we can let Matplotlib take care of the magic of turning it into log scale so we don't have to. So we do ax.setYscale, and we're like, hey, make it logarithmic. If we do that before we set the ticks and before we set the labels, the ticks and the labels, it knows it has to take this stuff and shove it in through the log conversion. So it'll do the log conversion and then label things appropriately in a logarithmic scale. If I do this, if I try to do this afterwards, though, if I do this here, which is afterwards, it's in logs. And the reason is because it already tried to draw those, and it already tried to place those. Since it already tried to place those and draw those, it has those, and then we're like, wait, that's not log. So it just dumps those and does its own thing instead. So if you want it right, you set it, hey, this is going to be log scale, and now convert the things following to log scale. So what do we know? By the way, what does this tell us about Titanic and most of the people on Titanic? What class were they in?
Second class.
Yeah, like our biggest band is kind of in the second class. But this is not the best way to show this, right? No. So we'll show like the better methods of showing this later. But first, we're going to be like, we have two pictures now, right? What do we want to do with our two pictures? Let's say I'm doing a report, right? I'm doing a report of like, this is the demographic data of the passengers on the Titanic. Here are their ages, here are their fares. What do we want to do with that, do you think? Exactly, put them on one. Matplotlib has wonderful machinery to put everything on one page. And that is a mix of the subplots machinery and the grid spec machinery. And it mostly depends on how fancy you need it to be. And then to get all your layout like clean so nothing is colliding to each other, we also have the constrained layout manager. So first step, right? Just multiple axes, right? The bare basic. I want the fares and I want both my fares and I want my ages on one chart. Subplots. So this is what I was saying. Subplots is a factory function. We can tell subplots, we use plots of subplots to be like, hey, give me two columns. Give me two columns, put them right next to each other. And so if I do this, I'm going to make one next to each other. And now we have a new method we're going to introduce too called soup title. And the idea behind soup title is it stands for super title. And it's the figure title, right? Each axis, each graph has its title, but then the figure, right? It's like report on Titanic. And then passenger, and then like ages, fares, whatever. So we tell it, and we're gonna suppress stuff again. So here, right, we're gonna have 1, 2. Right, no, columns next to row. What do you think I need to do if I want rows, one on top of the other? Exactly. Rows. That's all it is. We also have a grid. What do you think I need to do if I want a grid? Yeah. But what happens is I can no longer just unpack this. Now I make a little object called Yaxis. And I have them all next to each other. My little grid. X1, X2. By the way, when I'm doing these like quick little shows, I don't expect you to follow along. Like, it's fine.
How do we get more spacing between the
Layout, constraint layout, which we'll show you in a bit, or now. So let me just do constraint. True, if I do that, I'm gonna just call this for now, it tries to do its thing. So the constraint layout thing is like it uses the Kiwi solver magic thingy to figure out how do I place all of the titles and all the ticks and all the labeling and everything, like space such that it fits on my page, but it fits on my page in a way that nothing crashes on each other. So when possible, you really want to just use constraint layout and let it do its thing for you. If constraint layout isn't working, Matplotlib has 70 zillion methods that'll be like, dot adjust, subplot, 8, and then you can control like horizontal space, -1, horizontal space, top, bottom. Like you can tweak all these individually too, depending on your needs, but generally you want to let constraint layout do its magic. Yep.
When I type the plot and subplot, then I can find both subplot and subplots.
Oh,
What's the difference between subplot and subplot?
subplot, you know MATLAB. Yes, subplot is like MATLAB, which for those of you who don't know MATLAB, subplot makes 1. So subplot adds 1 axis to your image. So it lets you do them one-on-one. Subplots with the S lets you make multiple. And it's the factoring function that's like, I'm going to make you all of these subplots. Yeah. We try to be good. If there's an S, it means multiple. If there's no S, it means 1. Which actually, yes, is a terrible way to name things, but. Okay. 2. So now I have my fare and I have my ages. Or I have empty strings for my fare and my ages. How do I do, now how do I actually plot stuff on here, right? So, fare, right? Objects. This is where the power of object-oriented comes in, right? It's not when we just have the 1, it's when we have the multiple. So here, I assign AX1, right? Let's go back here for a sec. That one, this first one, that's AX1. Everything I do to AX1, I do to that one. Then what do you think that one is called? AX2, right? The second one is the AX2. So right, right, AX1, left, AX2. Okay. So here, question? Okay, so here I'm going to, on AX1, what am I putting on AX1 here, given this code? Ages. What am I doing besides? Okay, I'm plotting the ages, then I'm putting on the label and the ticks. What am I doing on AX2? Fair. Just the label on the y-axis. Okay. Okay, so that's the fair. And so, like we were saying, little bit constrained, little bit crowded. And so we're going to let constraint layout do its thing. And of course, this is when Vise got cranky on me. So okay. So we were saying constraint layout, it lets stuff breathe. So if you're doing multiple plots, always use this. So we want to make stuff different sizes, right? What if it's not, right? Fair and age are about the same widths, right? They're about the same thing. What if you have data like a time series and you want to plot the time series and right next to it you want to plot like a log plot? Do you want those to take up the same amount of space? Probably not, right? Like a log plot is pretty straightforward. Or what if you have a time series and then the eigenvector of the time series? Which, I don't know why you would do that, but let's say you do that. Right? So sometimes you have like one plot's really tiny, one plot needs all the space. We have a way to do that, and that is the grid spec API. The job of the grid spec API is to be like, fine, but I need professional, I don't want to open Photoshop. So here, the grid spec API, what it lets us do is it lets us, we can use the object, we can also shortcut, because 90% of the time you don't need the full object, you can just like, again, subplots, magical factory subplots, we're going to tell it, we're going to pass in a dictionary, and we're going to tell it like, here's how I need things to look. The most commonly one like I use are the ratios, and there's a width ratio and a height ratio. And you can set the width ratio, hey, make the first plot this much smaller than the second plot, this much smaller than the third plot. And the same thing with the height. So here, I'm going to make right plot be like 1, and then the second plot, the left plot, be 3 times wider. So this. Grid spec, I'm going to set the width ratio 1 to 3. I'm going to make a constraint layout because, of course, because I'm going to have multiple plots here. Shift enter and see. Our first plot is now 3 times a third of the size of our second plot. Because what's happening here is it's telling you, you're telling Matplotlib how to divide up the page, basically. Like, I have a page, now cut it up into 4s and allocate this way. And if we had more than, if we had like 3 plots, AX3, and cos equals 3, and now I had 6, now the page is cut up into, how many do you think the page is cut up into? 10. What's going to be the widest plot? The far left, yeah. See? So here, right, the far left is our widest plot, the far right is our thinnest. Okay. What did I do? Oh. So what did I do is that here, whenever we use subplots, we tend to just want to be like, if there's only rows or columns, we just unpack them one by one. If you have more than like 2, you want to start, it goes into an array, and you'll start indexing as you need it. Okay? I'm going to actually skip this practice so we can go on to the pretty. Is that okay? Oh, wow. Yeah, so let's take a 2-minute break and we'll start up again, which actually is perfect if you want to do this practice. So we'll give you like a 5-minute break and we'll do a 5-minute break or work on practice or both. And we'll start with 2. Okay, how many of you are in here because you're like, I want to make pretty pictures? Yeah, me too. Totally, right? Like, we need labels, right? Labels important. But now let's get to the candy. So, why do we make things pretty? Is it really just about the pretty? Nah, right? It's not just the pretty. It's also the information. So, right, in visualization, we think about this as visual encodings. When we change an aspect of a figure, the color, the line, the shape, the point, the width, the thing, we are telling you something about the data because we're encoding we're trying to encode another variable, right? That x, right? That x is the x data. It's the measurement at the x point of the variable on the x-axis. That y, that is a reflective of the measurement that we have for that variable. Often it's a straight mapping, right? We're going to say that that measurement is 2, so we're going to plot as a 2 on the x. Often we say that measurement is a 3, we're going to plot as a 3 on the y. Sometimes we do transformations, right? But we don't just do this in the x and y. We also do these transforms in the shape, the size, the color, right? We're like, here I have categories. Let's do our categories as different shapes, right? Let's say everyone who lived is a circle, everyone who died is a triangle. What does that give us? On a scatter plot, if I now have, besides my x and y, I now have a shape. How many variables can I now visualize? How many? 3. What if I now also am like, men are pink and women are dark blue? How many variables can I now show? 4. What if I'm like, I'm going to size the dots based on the age? Let's say I plotted age in the family. I'm going to size the dots based on the parents, based on the family size. How much information have I encoded in my chart? 5. Is this chart readable anymore? Maybe not, right? But you all have different domains, you have different use cases, you have different bosses. So you're going to need, right, to be able to customize your plot in like different ways depending on like what is the story you're trying to tell in this visualization. And the good part is everything on this graph, which is based on Bertin's semiology of graphics, is Matplotlib can do, basically. I think we can't do the line shape thing, but there's some weird stuff in line collection, so not quite sure. But everything else completely possible. So we're going to start talking about how to do this with lines. The reason why we start with, okay, this chart is this way because Bertin was a cartographer, and cartographers go points, lines, areas. We start at lines because we go 1D, 2D more. So lines are 1D, we only need one variable for them. Shape is, scatters and stuff, we usually have an X and a Y, at least 2D. And areas are the heat maps and name shows and stuff. So, new notebook. What do we need to do on every notebook? Import, right? Import all the things, get our data loaded up, and, right? Set the inline. So step 1, let's go. If you haven't been typing, like type all the things because it will stick in your brain. The only reason we know anything is because we've typed this stuff more times than we want to admit. Often wrong. Okay. Everyone's imported? Everyone having problems? Sticky flag? Okay. So import inline to set our backend, import pandas, so we have a data, import numpy, so we have more data set, and we're going to make the pictures. Okay, now, for the line plot, we're breaking from Titanic. We're taking a little bit from Titanic for the very simple reason that Titanic doesn't have what? My Titanic data set, what doesn't have in it? Anybody know? What? Yeah, there's no continuous data. There's no continuous data, there's no dependent data. It's all like individual measurements. So we're going to be a purist here and say line plots, we can only do a line plot if our data is continuous or if it's dependent in a way such that it's basically continuous. So we're going to instead do a sine curve. Good old sine. Happy sine. So here we're going to use the NumPy library. Linspace, anyone from the NumPy tutorial, what is this np.linspace doing for me? What? Yeah,
It's a set of linear space data points.
exactly. She's right, he's right, everyone's right. X.linspace gives me a set of points equally spaced on the number line between 0 and 2 pi. Okay, and now I'm going to pass this into np.signx. So what do you think np.sign gives me? Compute. Yeah, the sign for every value for which I have an x. So I'm using linspace here just so I have 100 points, equally spaced. So, well, you know, what is this going to look like? What does a sine curve from 0 to 2 pi look like? Exactly, up and down. So, make our sine curve, and then we're going to plot it. And this was not supposed to show, but oh well, right? So, make the plot here. We're plotting the x against the y. Right? So how is this different from the plots we did earlier? You know? Yeah, exactly. There's an x here. Instead of letting Matplotlib like automatically figure out our x, which by the way would actually still work here, but instead of letting Matplotlib do it automatically, we're gonna instead be like, here, I have x's. I want you to plot my x's. I want you to plot my sine x. Unfortunately, the coordinate system is going to be decimal, so we would actually want to relabel that to 0 to 2 pi if we were being kinder. But, okay. Okay, so run the code. Here, right, we're going to make the plot. What kind of things might I want to do to my plot, my line plot? Anyone? Make it purple. Is that my first example? Okay, so we're going to make it purple later, but first, let's see what actual points we're plotting, right? Because are we actually plotting like continuous data? No, right? We're plotting a sample. Our sample just happens to be really tight. So first, let's look at our points. And we've already done this. We did this when we did the markers. So here we're going to set the markers to stars. And I realized I want to just make the line style empty. And I'm going to blow up the figure. I'm going to use the fig size keyword parameter here. So that fig size is equal to 15 by 5. Matplotlib, we are width by height. And because this confused me, Tom was like, how do you measure paper? Yeah, because paper is width by height. So that is why fixed size is width by height. So we're 15 by 5 here. And we pass in a marker. We said our marker is equal to star. Our line style is equal to this. Line style is equal to none. If I do that, you have no line underneath, right? If I don't set this, I get both. I get my marker and I get my line underneath. So here now, I'm like, this data, is it sampled really frequently? If I decided, for reasons I didn't quite know, to be like, let's make this to 10, how do you expect the markers to change? If this was now 10, and I plotted this, what would the markers look like now? Yeah, very spread out. I mean, our graph is also now more spread out because it's doing this interpolation now between the wide spaces. So let's set 100 just so it looks like your notes. Okay, but if I do this, right, what's the problem? Now, can you see these markers clearly? Nah, so what might we want to do so we can see our markers pop? Yep, I mean, we can do both, really. I think that we do later, but, well, here's the problem, right? Like, if we make the markers bigger, let's do this, right? If we make the markers bigger, and that's the marker size, these are really, so does that help in being able to see the individual markers? No. No. Yeah, we change the color. By the way, the other thing we're doing here is the aspect. If we don't do the aspect, apparently nothing changes here. Oh, because I set the fig size. The fig size is wide enough that this doesn't make a difference, but if I don't do this, it looks like this. It's kind of smushed. If I do this, it looks wider, because the aspect, now we have an equal aspect ratio. Okay. So let's change the color. What do you think would be the parameter to change color? Marker color. And what else? If I want to change the line? What? Close. Color changes the line. So most of the Matplotlib plotting functions have a color, and the color changes the main thing being plotted. Like here, line is the main thing being plotted, so color will change the line. In scatter, dots are the markers are the main thing being plotted, so a color will change the markers. In histograms, like the color, we always have a color keyword that will change the thing being plotted. So we have color to change the line color, marker, and you can't change the marker color, obnoxiously enough. You can change the marker face color, and you can change the marker edge color. And you have to set those. So here, I've decided that I want a flag. So I am setting my face color to white, my edge color to blue, and my other color to red, and I actually possibly should make this size bigger to show this. So, and of course, and now I can't see my colors. My line. Of course not. So this lets us change our color. I want you all change the color combination. Change up this code and post your most obnoxious color combination to the Slack. Someone have a very obnoxious color. Someone want to give me an obnoxious color combination to try? Okay. So Matplotlib's color is wonderful in that we support, like, if the color exists, there's a way we support it. And what I mean by that is, if you have the HTML codes, you can pop the HTML code right in. So like if you have a insider style sheet and it has HTML, we'll support that. If you have XKCD colors, the 100,000 like name stuff, support those. We support all the X11 colors. So if you're used to Unix or like Unix, GNU plot, any of those, there's about like the yellow, greens, and the light blues. If you want like a custom RGB tuple, we support the RGB tuple, so you can call it by the RGB, 3 digits, I think, and then you can always use converters to get from HSV to RGB. So if you can dream the color, like if the color can be displayed on a screen, there's probably a way to get it to show up in Matplotlib. Okay, any other color combinations someone wants to throw my way? Okay, and things need to be bigger. Actually, here we can, yeah. It's a little bit too, the edge is a little bit too big. And for the record, yes, you can make the edge thinner. Because again, it's all super customizable. Okay. So we can do the line, right? We can choose the colors. We can change the size. Right, sometimes you need thinner, right, this is another branch of our table. We can do the size. So we have both. The markers we can change using the marker size key parameter, and the line width we can change using the line width parameter. So here, 2020, and I'm also going to actually. I'm modifying the fixed size here to make things bigger, to make things show up more, right? And you see, right, when I make the fixed size bigger, the line width looks smaller, even though it's the same size. What other things do you think I should try here?
Can you change the width of the marker edge?
Yes, actually. Yeah. Ugh. But we want really a marker edge color here for you to like really see this gloriousness. What color? I don't know. These are all too. Oh. Have a marker. Yeah. So the funny part about this, right, is like you can basically make your own hatches on your lines by setting up your markers in the right way. Yeah. So that's a marker edge width of 1. A marker edge width of 10 looks like this. So what we're doing here, right, is we're starting to like layer on. Okay, so now we've got color. We can change the color. We can change the width. What else? What is like a typical thing you all need to do to line plots? Dashes. How many of y'all have to make dashes? How many of y'all work in environments where you have to make a colorblind report? Black and white only? Right, so dashes are helpful when like we can't kind of use the full color space. And so we have options. Dashes, we have a whole bunch of styles. Oh, and sorry. So if we look at the gallery, which is also the tutorials, we have all of these references. So the quickest way I found is just do a find in the page. And what you'll find is a full reference of like, here are all our possible line styles. And here are all the possible markers. And somewhere in all of this is here are all the possible colors. Vaguely. So we have like your solid, your dashed, your dotted. And by the way, when I say all possible, you can also make custom. Like you can make custom markers. So if you want those like weird, if you want a pie scatter, you can do it. I don't recommend it, but you can do it. Okay. So here, I'm going to make a dashed line, a dash dot. I'm going to make a dot. And this is too small for you all. So equals dash dot. Okay, control this. Right. Make this nice and big. Here, line style equals dash dot. And what's going to say? Okay, so this is a continuous signal, right? What if we want to show the sampling, kind of? Like, what if we, like this would be an analog, right? If I'm plotting an analog curve, what if I wanted to plot a digital curve? So we can do this line style, right? We can change the x. What the other thing we can do is be like, I am going to force you to see the sampling rate. And the way I'm going to force you to see the sampling rate is I'm going to, instead of drawing you a smooth, continuous curve that I interpolated, I'm going to draw you a stepped curve. So we set the draw style parameter that I learned about yesterday to draw style. We said draw style equals steps. And that'll let us set this kind of stepped curve. So now we're showing you the digital sampling. Right, so do any of you have use cases where you'd want to do this kind of thing? See, someone. This is why it exists. Matplotlib, we're an open source project. If it's in the code, it's because someone thought it would be useful for something. Okay. So here, right, we're going to set draw style equals subs. And as you can see, there's a pattern emerging, right? How is it that we configure these kind of stylistic, how do we configure aesthetics in Matplotlib? What are you all seeing? What's the pattern in how we configure aesthetics? These kind of aesthetics, the visual language of the plot. Exactly, as a keyword into the function. And how is it that we configure not the visual aesthetics, but the setup of the plot? The like text, ticks, label, like those kind of things. The template-y pieces of it. How do we configure that? Exactly, object methods. So we go object methods to do the labeling, ticking, kind of anything that's not the drawing of the actual visual plot, and the function parameters for anything that sets up the aesthetics of the plot. And this is equivalent to, I think, like how other libraries, if you're used to, will also do this kind of thing. So the reason why, like, this is another thing, like, you should pin, is when you're going to be later, like, how in the world do I make a bubble scatter thing, bubble scatter heat map? Where do you think you need to go to look for the bubble scatter heat map? Yes, you can make this thing. For the record, a bubble scatter heat map is just a choropleth map with points. Right, so there, right, to do the bubbly pieces of it, right, like the aesthetics we're going to do inside the functions. To do the labeling coordinate stuff, that's an object on the axis. It's like, or another way to measure it, are we messing with the grid, or are we messing with the thing we're drawing on the grid? Okay, so legend, right? I only have one plot here. How many times do you have to make a line plot where there's only one thing on the plot? How many times do you have to make a line thing where there's 2, 3, 10, 20 things on the plot? Right, so legends are crucial here. We have beautifully terrifying legend code that is magical. So I'm going to make a sign plot. And the good part is legends are really simple. To make a legend in line, what we have to do is just tell Matplotlib what the line is. We're like, hey, this line, it is a sine curve. Great. Once we tell Matplotlib this line, it is a sine curve, the legend machinery will automatically pick that up because we put that on the axis. We told the axis, hey, this thing is a sine curve. So the legend knows to go in and collect that, and now we can do AX.legend and we can pop that up. And yes, there are 70 zillion ways to configure the legend. There's a guide on it. We can move the legend, we can like add columns, we can make it super pretty, super disappear, as need be. So, and the thing is though, the machinery is magical. It'll pick this up for more than one plot. We can just add stuff to the plot and it'll pick up. So here, right? What I want to do is x. Let's plot x against x. And line equals x, not line. Label equals x. See? And it picks up both. Yep. Question? Someone had a question?
I did, but you already answered it. My question was, does it default to the upper right-hand corner as it was in your first plot? But
No,
it goes wherever it goes.
the default is to do best, which is some algorithm sitting somewhere for like the optimal position so it doesn't collide into things. When best isn't quite best, you can pass in a loc equals, and there's like an upper. Is that how it works? Yeah. There are 3 ways to set these things. Actually, did this one go in yet? We've been debating whether that will work, but apparently it doesn't. But the good part is we're trying to be nicer to you. So when you give us something wrong, we'll print out like, here's what you can choose. These are your options here. So you can do human readable. Also, if you're coming from MATLAB, you can do the MATLAB locations, the 0, 1, 2, 3, 4, 5, 6 grid. So, and 0 happens to be the right corner. Forget where this is. 0 locations. So let's give you 5 minutes. Add a cosine. Add a brightly colored, brightly textured cosine. I'm going to try to do something. If I don't do this, what do you think is going to happen? If I take away the label, but I try to make a legend, what do you think is going to happen? We tried to be semi-kind here in that, like, the plot will show plot because you didn't do anything wrong. You just tried to add something that, like, doesn't know what it's doing. So here the legend is just going to yell at you like, hey, I can't draw myself because I don't have a thing to draw. So handles, when important terminology, that why? Okay, handles. You will see handles all over the Matplotlib legend code. What we mean by handles, what Matplotlib means by handles is that is the thing you're trying to plot. That is the like point or the line or the like the marker that I'm trying to give a legend for. So handles traditionally is like this plot, it's going to return like this object, this little like object that stores the line. It's called the line collection, or it's going to store this object that's like what's called a patch for the marker, or like it's going to like, but a thing that it's trying to draw. So that's what the Matplotlib means by handle. Handle is like, what is this thing I'm trying to give you the legend for? And then the label is the label, like the sine curve. So a way to think about it is actually, let me because it's going to be easier, I think, to do this way. Label equals sine. What we mean by handle is this thing. That little line there, dashy line thing, that is the handle. That is the like thing I'm trying to give you the key for. And that is represented in like Matplotlib code, right? We have a representation of that because we have to have a representation of that because we can't draw it if we don't code it up. So when it's saying I have no handles, it's saying I don't have that. And the reason I'm stressing this is because some of you all might need to make very complicated legends that don't quite work with like, they can't quite do automatically. And what you're going to want to do there and you're going to need to do is make your own handles. And you can. You absolutely 100% can make your own handles to make your own very custom legends that show the keys for exactly what you want. And that's what we mean by, and then you'll pass in your labels. And we'll do a little bit of custom labeling later. But, yeah. Okay.
Can you put your legend outside the graph?
Yeah. I don't have it here, but we have the like very wonderful legend guide.
If you go Matplotlib, put
Yep.
legend outside of Axis, something like this file is
Yep.
the right answer.
But also it's in the legend guide. We have 2 examples here. This is a common one. This is another common one. And that's the good part is if you want a legend like up on top, we also have a way to expand it so it'll fill up the entire space. And we have this kind of column stuff so you can like get them all in the same line. Like I said, there are multiple. And then here's the stuff about like making your own custom stuff as you need it. Okay. Okay. So everyone has a cosine? Cool. Okay. So let's now go back to the Titanic. Okay. Oh, actually, let's just do a very brief thing here. I'm just going to add the cosine here, right? X dot plot x, p dot cos x, and I'm going to label equals cos. So what here just add a cosine, I added another plot to the same axis. I threw in the cosine, I labeled it. Okay, let's make scatters. Okay, back to our passenger records, right? We have our beautiful passenger records, because, again, I'm morbid. I'm very curious about demographic breakdown in Titanic deaths. And we have all these variables, right? We have age and fare and sex as recorded in the logs and, their class and where they came from. And some data sets actually have a body, but I don't have that one here. And like the thing most interesting here is like who died. And so we want to tear that apart. And which visualization is really good when we're like kind of trying to throw all the variables at it and to see what sticks? Maybe? Exactly, scatter plots. Scatter plots are a visualization of choice for multiple variables when you're trying to figure out dependent relationships. So we're going to make a scatter. And we're going to just keep layering on more and more visual elements until you guys decide this is the breaking point or I decide it's the breaking point. Okay, so first thing first, we're going to read in our CSV. And now data cleaning becomes important, unfortunately. So we're going to use the drop NA method from pandas, because the job of the drop NA is like, what do you all think the drop NA does? Yeah, it drops the nulls. By default, what it's doing here is it drops the rows with the nulls. So because right now I don't totally care about this data set, I'm going to just do a big old, let's drop any row where I'm missing any data. If you were doing actual analysis, there are smarter things to do. But step one, I'm going to drop my NA. Okay. Next, I'm going to do a head. And the job of the head function is, data frame is, any of you know Linux head? Linux head, okay. Linux head is if you want to see the first 5 lines by default of your file, you can type head into a command prompt. Pandas is stealing that and being like, head, I'm going to give you the first 5. Why is it useful to look at the first 5 rows of your data set always without question?
Structure.
What? Structure, make sure what you think it is. Make sure that your data set, if it's in Russian, it hasn't decided to convert it to Greek. Yeah, always look at your data. So here, right, like we were saying, we have our passenger class, which is categorical. We have our survived categorical. We have our name, which is free text, so we're not going to deal with that here. All our variables. Also, this gives us our columns. And what we are going to do is, let's just display data, right? Let's do a bare minimum scatter plot. What are 2 variables that are good for just doing the basic scatter? Age, fare, right? Let's go back to our babies. So here, I'm going to grab the age and I'm going to grab the fare. I'm going to plot, which one's on the X, do you all think? Oh. And Y? Yeah, so scatter takes the X first and then the Y. We're going to plot. Do we see any correlation between our variables? No, not really. That's okay. Doesn't have to be. So here we have an age and a fare. And this is going to get how many of you are already annoyed with having to type df open bracket age, close bracket age every time? See, 1, 2, 4. Yeah. So, and this one's not so bad, right? But what happens when we start having 3, 4, 5, right? We don't like this. So what we do is Matplotlib gives us a way to access structured data in a just by key. So, and that is called the data parameter. You will see me use keyword gog, you'll see me use this word, which is not a word, which stands for keyword argument, interchangeably with parameter, interchangeably with keyword. As far as I'm concerned, they all mean the same thing. Hardcore, legit compiler people will yell at you repeatedly. Ignore them, it's fine. So I'm going to simplify the code using the data. And so the way that works is we say, I want this column on the X, I want this column on the Y, and I'm going to pass in the data equals that data frame, I'm going to pass in as data. And so now, instead of having to subset into the data frame to pull out my columns each time, I can just be like, you Matplotlib, you go do the unpacking for me. And this becomes really powerful once you write your code gets really complicated, or once you have to start building stuff for other people to use. So here we're going to unpack. Okay, so I have this. What am I missing? Labels. Okay, how many of you are sick of having to do ax.set x label, ax.set y label, ax.set title? Yeah, so we have a fix for that too. We have this set function. And the set function is a broad set function. So we can pass it, hey, set. We're going to set the x label equals, the y label equals, and the title equals. Okay? So set it, forget it. We have all our titles. Okay, so that, and again, I'm sort of, tell me to slow down if you're trying to type. But, right, so we're going to set here. What might I want to do now, though? What am I really interested in again? Survival, right? I want to know who died. But actually, before then, I'm going to just change the color. Blue is kind, blue is lovely, blue is kind of boring. So, like line, we can pass in a color. Like if it's just about changing the plot on the color, we pass in a color. And the color changes the color. Simple as that. Also, I'm just going to do one thing quickly because I'm actually sick of y'all getting to see everything before I plot it. Even though I'm pretty sure the slides all have it too at this point. Okay, great. I'm going to re-import you. And I'm going to grab my data again. Okay. Great. Okay, so I like hot pink. We're going to do hot pink. Possibly not appropriate, but right now we're still plotting age by fair, so it's fine, right? Okay. But like I said, I really want survival. I really care about survival. How can I plot the survival rate? Anyone know? What would you think of as one way to plot the survival rate? Not survival rate, sorry, to plot, how do you think I can show in my dots who survived and who didn't?
Either fill them or unfill them, or change the marker style.
Fill, unfill, change the marker style. What's kind of more straightforward? What's kind of like just pop more?
That one's red.
Yeah, two colors, right? One for dead, one for live. So we're going to do that. Matplotlib lets us do this automatically because in this case, our survival data is a 0 and a 1. 0 and 1 are numbers. If it's numbers, we can map numbers to colors. We can we need to map words to colors. That is a long-standing wish list. But we can map numbers to colors really simply. And we do. You pass in the column into C, C equals survived, and it's going to take the survived column and it's going to map it to colors. So, here, I have living, I have dead. Do I know which one is which? No. It happens to be, it goes 0, 1, and on this color map, it goes dark to light. So the purple ones are living, the red ones are dead, the other ones are dead. Yeah, but this isn't friendly, right? Also, are these great colors? No. Or at least I don't love them. So let's customize, right? Let's use colors that are like better suited for our like live died. Also because then we know which colors we're using. So we're going to do here is, I'm going to use the Tableau 10 color map. Matplotlib has a whole bunch of them. You can find them in somewhere in here. I wasn't kidding that we have all the docs. So So here's a color map reference. Whole bunch of color maps. So I'm going to use the Tableau 10 color map. And I'm going to set it. And what, do you think this will work? Do you think I'll get a pretty picture? What? Still don't know how to interpret, and it happens to be in this case, colors are, they're too close to each other, right? These are similar. So what we're going to do instead is we're going to actually make our own. Because sometimes you just need to make your own color map. And I should have done this first, so guys, when I start saying stuff that like jumps 4 steps ahead, stop me. How many of you know what I mean by color map? Oh, great. Y'all are awesome. For those in the room who don't, when we mean a color map, what we're saying is we have our data, and right, data is not color. So our color map is a lookup table that says, hey, this number, make it this color. The way this is done in Matplotlib is through a system called norms. And what the norms are, they are the set of rules that say map this number or numbers in this range to this color or these colors. So that's how that machinery works here. So the idea is we have the individual colors, like the line, color equals line, the color equals hot pink, you know, for the line or the plot, but we set it ourselves. And then we have the CMap system where our numbers that we pass in go through this norm machinery to get you a color. And so what we're going to do here is we're going to make our own machinery. Because we only have 2 values, we're going to use this listed color map. And a listed color map is one of the simplest color maps you can make for yourselves, because what it is you list the colors you need. So here I have 2 classes. I have live and dead. I'm going to color my dead people dots black. I'm going to color my live dots yellow, green. And the reason I know here which one is which is because, like I said, the way the norm machinery works, it goes 0, then 1. So 0 is dead, live is 1. So here, set. Now, right, is this a little bit easier to see now who lived and who died? Are we starting to see separation in the data? What did people always say about the Titanic, by the way? Who is supposed to have survived the Titanic more? Women and children. Do we see in this data children surviving more? Where do we see more white dots, yellow dots? This side of the scale or that side of the scale? Left, right? We actually do see more. We see a couple. We see a cluster on the 0 to 10.
It's driving me nuts that the markers are on top of each other.
Yeah.
Is there a way you can turn off the face color?
Kind of, yes. We're going to do that, I think, next. Or a little bit after, right? This is great. We still don't have a legend, right? And we really need a legend, right? Because we don't want to have to automatically remember in our heads the order of things. Yes? So we can do a legend. This is a brand new feature in Matplotlib 3.1. So if you don't have the latest version, this might not work, and I apologize in advance. But we can do the scatter legend. So if you return, and so now we set scatter. So let's actually go back for a second. Here, right, we've been setting scatter to nothing, underscore equals, because we didn't care. Like, we didn't need the output of the scatter. Now, though, we need that output, because we're going to make a legend based on that output. That output gives us our handles that we can pass into the legend. So here, I am going to set, so here I'm going to set SC. So I'm going to have that output. And what? Oh, I see what you mean. Yes, sorry. Okay. So I'm going to set SC, and I'm going to then pass that into legend elements. That splat in Python is that sc.legend elements is a list, and that splat, the asterisk, it's called the splat operator. The asterisk is called the splat operator, and its job is to break the list into its individual elements. So here, because the AX wants the individual elements, so here we're going to do that. And now we have labels. What do you think about these labels, though? Terrible, right? Are these labels helpful? No, right? So what we can do next is we can pass in, okay, the legend elements you need to know, it returns two lists. It returns the handles and it returns the labels. So the handles are the first thing it returns. So here we tell legend, hey, grab the handles from the SC, legend elements, because it has the handles there, but don't use those labels. I'm going to tell you what labels to use. And I'm going to say, hey, I'm going to write the labels, died and survived. So I tell it to do that, and it survived. Any of you ever use data camp? No? One. Okay, because I was going to say, data camp does some auto magic under the hood to make this a little bit easier. That doesn't work in real life. Yeah, no, seriously, because, yeah. But, yeah, so if you're going to need, what you do is you grab the handles from SC elements, that's the first one, and then, like I said, you set the labels manually. And this is actually easier than it used to be to do this. So I'm going to do that. And let's clean up. Okay, so right here we set our labels. And like I was saying, I'm gonna actually run a little bit because I just want to clean it and then, yeah. So we're gonna clean up a bit. This is the thing you were said, you was driving you nuts, right? Why are they all on top of each other? We can, and yes, at this point, this gets a little bit breaky for my little Jupyter hub. We're gonna start setting transparency. We have too many markers, they're all on top of each other, so we can set the transparency. If we make our markers transparent, right, then we can start seeing how they stacked on each other. So we can set alpha equals to 0.5, and that'll set the transparency.
Okay, but you could also just make them.
Yeah, you can set alpha equals 0. But the problem is that the color only changes the face color, not the edge color. So the edge color gets set on the entire set. You see what I mean, right? Like if you, to set the edge color for each set, you wouldn't be able to use the C equals parameter. You'd have to like set a different edge color for each group. So if you're using this machinery, the color map machinery, then your best bet is to set the face color alpha pretty light. And so then things are pretty transparent. See? Once you start setting the alpha pretty light, you're going to start seeing like pretty good separation. Anyways. Okay. How many variables do I have so far encoded on this thing? 3, right? I've got fair, age, died, survived. What else might I want? Anybody? Anything? Male. Gender is 1. Male, female. I'm going to go first because it's bubble chart. I'm going to do a quantitative thing. And so in this case, I'm going to do the class they're in. So any of you know what a bubble chart, what is a bubble chart? Exactly. Exactly. A bubble chart is when we size the scatter based on the data. So bubble charts are particularly good when we only have like 2 or 3 classes that we're going to do the sizing, because it's really clear to see what's like which size correlates to which class. So here we're going to size the data using the P-class column. And the reason here we can't just use the data machinery, we could normally use the data machinery, but there's a little bit of a problem there. What do you think the problem might be if we try to use the data machinery natively here?
You're multiplying a string times 5, right? So you have like P class repeated instead of
Yeah.
the X value.
Yeah, it's because the P class is so small, because it's 1, 2, and 3, that if you try to set that as the size, are those visible to any of you?
The size is in square pixels.
Yeah. Yeah, how many of you can see those dots? How many of you can make meaningful interpretations about those dots? Yeah. Yeah, so we're going to explicitly pull out the P class so we can multiply by a scale factor. So now we can actually start popping out the differences. So what do you see at the bottom here on the fair, right? The fair should be related to the, which dot should be the biggest? The dot on the bottom or the dot on the top? Remember, dot's size is the class and the y-axis is the fair. So how should dot size be related to y-axis position?
The dot should get smaller as you go up.
Yeah, exactly. The dot should get smaller as you go up. And is that happening here? Kind of, sort of, maybe. Right? So we can do that. Okay. Any more information we can code on this? What other visual attributes do I have?
The pattern on the film, you would change the hatch on the dots or something.
Something like that. I mean, I don't think you can. Yeah, I don't think you actually.
It's definitely one of those you can, but you shouldn't.
Yeah, but I also think what you possibly meant is that the shape. Yeah, you can do the thing with the shape is you can't do that. You can do the shape. You can't do the shape in here. What I mean is that you can't like pass in a column and they'll just shape it differently. That you have to stop. You have to break out. You have to select like let's pull all the women. Let's pull all the men. Actually, let's pull the males. Let's pull the females, and assign those each a different marker. But you can, so that's how we're doing this here. Is we're going to subselect to female, which is what this lets us do. And we're going to subselect to male. And we're going to plot. And again, this is starting to get into the like, how many of you have had to make plots like this for work? Yeah, so this is a thing like people actually have to do. Is this a good idea? More questionable, right? But you can do it, right? You can make the like male, female. And this is the point actually where you have to start making a custom legend because the legend machinery will not pick up all of the things. Which makes me sad, actually. Yeah, no, make the request. Okay, so, because actually what I want you all to do now is practice, right? Let's take it till 11. Yeah. Yeah. And what I mean by practice is try using other variables, right? Like how can you unpack this data in a different way? What pattern can you find? Make that legend, play with things. Yeah. So, that's what I want you to do. I want you to now, we've been looking at fair and age and gender and fair and age and sex and something else. So now I want you all to let's look at family size too, right? Did people with larger families live because more children, or did they die because they were trying to find their toddler? It's a Titanic. Okay, So I wanted to explain, I also want to know, like, how many variables do you think you can, like, shove in there before this thing gets unreadable? Okay. How many of you have been reading these scripts and are like, this is too tiny, you need to make things bigger? Or you're like, this is great, but on a presentation, this is going to be unreadable? So, we have options. Of course we have options. We pass in the font size keyword, and I'm like, 96. Pass in the font size equals 96. It'll blow it up. Okay, maybe this was a little bit too big. 24. So you can control the size of your fonts using the font size keyword. On ax.set, you can do it, but it's a little bit like magic. So, but actually, I forgot. Ugh. Okay. There's a way to do it on ax.set too, to set the font sizes, but what you're going to want to do is just look up the Matplotlib documentation. This is how I look up documentation. It's often faster. So we look for set. Okay, to set. Okay. And, okay, so actually I'm gonna do it out of scope here, but you can look up how, like, what is the font size argument it's a set if you wanna set globally your font sizes. Also, we didn't talk about it here, but like, if you're working in a corporate or lab environment where all of your images need to look the same, what you can do is you can set a style sheet. So we have, I'm gonna like just take that up. And there's a tutorial for customizing with style sheets, but the idea is you set a style sheet and then you can make all your plots like with my style, with my style, and then plot everything inside, and then it'll style the axis and the images based on what you set as the style sheet. And so that's good for setting the fonts and the labels and the titles, and again, all that stuff that sets up the grid, and then you'll just worry about setting up the aesthetics inside. So if you need like custom stuff, or like if you're writing a paper and you want everything to look the same style, making a Matplotlib custom style sheet is the way to go. You'll see people telling you to mess with your RC params. Don't. Okay. Okay, where is this? So. Okay. Well, we're going to, and this is just a demo, and then we'll jump to the next sheet, which is histograms and stuff. But Matplotlib is like, it's interactive in like useful ways. So here, I'm gonna do the age and the fair, and I'm gonna decide like, I want them to share an x-axis. And what I mean by that, and you don't have to run it, like this is purely demo, is that if I decide to zoom, I can zoom, if I zoom here, both zoom together. So we have this interactivity of like zooming together, and we did not have to do any work, extra work, except this share x equals true. That's all we had to do. And this works for x, this works for y, this works for we can do a whole grid and have a whole grid linked together. So easy breezy interactivity. And this is using the notebook and the widget backends. Okay?
To restart, if you change, you have to restart the kernel.
I didn't, but yes.
Should we say that?
Yes. You often, if you're going to change between inline and widget, you have to restart your kernel because you can't do the two of them together because they are cranky. Or what happens here is that I get this like ugly old school NVAG because that's what it defaults to. Okay. And this is the extra credit. Actually, one sec. Okay, yeah, so we can go in two directions here, because I'm looking at like an hour left. Histograms, bar charts, pie charts, or heat maps. Okay, raise hands for histograms and stuff. We'll also do heat maps, just like okay, and raise your hands for bar charts. Or those are the same sheets, so like, raise your hand for heat maps and stuff. It's kind of like both. Okay, we'll do okay, so we'll do a gloss on histograms and then get into the nitty-gritty on heat maps and stuff, because the histograms and stuff, they work the same as the scatters and the bars and everything else there. Okay. Here's the good part. Do you all know how to label things now? Do you know how to create a graph? Do you know how to label things? Do you know how to call a plot method? You know how to use all of Matplotlib. I'm not totally kidding here, actually. Like, once you have the basics, they're all kind of interchangeable. Like you saw, right? The way we use plot was very similar to the way we use scatter. So, okay. Vision. Images. Okay, again, new notebook, and I know some of you are just running stuff in the same notebook, which is probably the smart way to do this. But new notebook, I'm going to load in all my data again. I'm going to drop my NA. This is notebook 3 aggregation. Yeah, and I'm calling it aggregation, not because we are doing a little bit of aggregation here, but more because I just wanted to, because like right now is when we're starting to process our data. Matplotlib is mostly not in the business of processing your data, by the way. We try as much as possible to be a straight visualization library. You do the math, we make the pictures. Occasionally, though, because for historical reasons, Matplotlib was trying to be a PyPlot MATLAB clone-ish before, and this was before like NumPy and SciPy and Pandas were more fully featured. Matplotlib will do some math for you, but as much as possible, like, it's not trying to. And really what's happening is under the hood stuff is getting passed off to SciPy and NumPy and whoever as much as possible. So that's the preamble. We're gonna make plots, right? So, remember our ridiculous little passenger-based ECDF? What would be a more useful way of seeing this data? Right, now that we've decided, like, we're setting this up so that we have these bins here. Read off, tell me, what was the largest age group of my passengers? Adult. Right, adults are my largest age group. What would be an easier way to read off this exact same information? Yeah, heat map, right? We can do counts, we can make our heat map. So, and this is why I want you guys to actually, not a heat map, sorry, histogram. And this is why I want you all to start coding again, right? Let's learn to use our histogram. Quieter or slower? Okay. So, let's make our histograms. So, make a subplot again, and we're going to add in an age. We're going to do an age, but here we're going to histogram the age because that's what we're interested in. We're going to want to replicate our line plot, and we're going to let the bins be auto. Bins auto is auto magic on NumPy's part to try to make the optimized number of bins. Like, it does some kind of distribution function to try to equalize. He says there are 4 pages of explanation on this. I linked to it. But if you want to try to let it do its thing and give you good bins, you can say auto. And what the histogram returns is the counts, the edges from NumPy, and then that underscore is everything else, which is like all of the Matplotlib stuff that actually makes the histogram. So we hit enter, and I made a histogram. Okay, reading off this histogram, what is the largest age group on the Titanic? What? 35 to 40. And right, this is a good histogram. I have a question. What bins am I kind of more interested though in? The census bins, right? Because I've been using them. So let's, instead of using this like histogram that's just magically doing stuff for us, we're going to use our own bins. We made them. We may as well use them. So, gonna do, and we pass in our bins. Just like we pass in our x-axis, y-axis to set our ticks, we pass in our bins. 0, 25, we pass in our data, and I'm gonna set my ticks to match my bins. And I have my bins. By the way, what I actually would want to do instead, what would we really want to do instead of this for our ticks? If I wanted to show what each bin was. Relabel it, right? Shift everything over, right, by like a half, and then relabel.
Is there a way to make the bars separate? Not separate like a bar chart, but like a line that delineates where the bins are breaking?
Width equals 0.9.
Wait, what?
I think with the keyword argument, width equals 0.9. There's a 70% chance that's gonna work right.
Okay.
Well, I remember if it's a fraction or an absolute unit. So there is a way to control that. In older versions of Matplotlib before 2, we default to small bins. And in 2, we defaulted to bins that were the full width of their range. So if you're binning, because if the bins are narrower, you might say, oh, there's no one between 19 and 22, because there's no bar there.
That being said, it's actually no.
I think he was asking the same thing I was thinking, is can we just have a line drawn?
Oh, you're just on lines.
bar?
Yeah, they want bar charts.
So I can see the
No, not, I
delineation.
know it is degree,
Yeah.
it has no space between the bars, but you can't just put some lines around. It's just a big clump.
Oh, so what we can do instead is this. Hold up. His type equals step. Instead of the clump.
You can also pass edge color equals white.
Oh, I get what you mean. Okay, because the histogram is really under the hood drawing a bar chart, if you set edge color equals white, it'll give you the bars.
Now, here's a quick question. How do you get it to stop ignoring the data above 64?
Is there data above 64?
64.
Yeah,
For somebody older than that.
yeah, you just, the other way to do it actually is, that doesn't work, they usually just work.
Yeah, I wonder if there was just an easy way to say,
Yeah.
give me one more.
Max of the data.
The bins are left, final right.
Actually, you can decide if they're right, left, or mid. Something like that, yeah. Yeah, here,
So a lot of
here, it's the,
data science, we're used to making data-centric code, so
Yeah.
you wouldn't want to have to know what that number is. You want to
yeah,
let the data tell you what that last number is.
That's what auto does.
yeah. Yeah, auto will automatically set the bins for you. Here, I'm like, I'm manually setting my bins anyways. Yeah. But you can also pass in weights if you want to weight your bins differently and stuff. Like if you're trying to do representative sampling reallocation, you can pass in your weights. Okay. So, yes, but if you want your separation, you can do this here. Because like I said, under the hood, what histogram is really doing is it's drawing a bar chart where the count is the x-axis and the count are the y-axis and the edges are the x-axis. So you could also take this out and make your own bar plot. Which, by the way, also, so if you want like black, and then you can also do this. This color equals white. So you can mess with this kind of as you please. This also takes hatches, by the way. You could hatch your bar charts. What? So hatch is going to be something like that. Yeah. Yeah. Oh, yeah. So yeah, you can kind of do, so like anything else, we can customize the color, the shape, the texture. Okay. We can also compute the probability density, and the probability density is basically the probability of the data. Instead of giving you the histogram, you want to just give me like, what is the probability of this occurring? So, and that's really simple because it's just the density keyword arg. And the reason this works is, again, because what histogram is doing is two operations fundamentally. It is passing code to NumPy's histogram to compute the histogram, and then passing code to Matplotlib's bar to make the bar charts. It has, yeah. Okay, so what I want you to do is make the histogram of the fares. Then make a histogram of the fares, style it in a way that makes sense to you, and use the bins that we've defined before. So my fares, right? I've got fares. I've got, and what are my bins on my fares? No, on the fares. 12, 30, 870, and I'm going to just do 1,000,000. Oh, good to know. Perfect. So generally, if I'm looking at this data set, are people pretty broke? What did I break? Okay. That didn't work. Because almost everyone paid between 0 and 3. Oh, this is what it's mad about. Where did I?
You're plotting the histogram of a single categorical right now. You spelled fair is wrong.
Oh.
It's fair, singular.
I love categorical, but it can be annoying in some ways. I'm allowed to say this, though, so. What? Yeah. Well, most people really paid between some under 870, but yes, our third. Yeah. What? Do auto bidding? Yeah. And our auto bidding says most people actually paid between like 200 and that, but the problem is as our bins are so small, right, that most people end up like on the first class berth price point. Right, so this is the fun part about binning. It can like make things look weird. So what are we doing here? So this is a little bit of panda magic. We can do a group by, and the job of a group by is like, I wanted to know by gender. So I can separate by gender, group by gives me 2 data frames, and I'm gonna plot each of them. I can plot, when the idea here is I can plot one histogram on top of the other, because it's just an ax. So, and by the way, on the same axis, I can still put a scatter on top of this, and I can do a line plot on top of this, and I can even do a heat map on top of this. There's no limit. You can do pie charts. Like, you can actually shove all of them. There's probably a limit to how many things you can shove on the plot, but I think that's your computer limit, not a like physical, like there's no check, hey, if collection's greater than 3,000. So theoretically, you can shove as much stuff on top of the plot as you want. And the practical implication of this is we can make like histograms of 2 data sets here. And that's what we're doing here. We're plotting our males and we're plotting our females. And like our previous sets here, we can send in the alpha equals 0.5, and we can send in the the bins, again, we can set in the alpha so we can make stuff see-through so we can layer them on top. If this is still a little bit too much, there's a thing called histype equals step with 2 T's, which will kill everybody, but 2 T's, and so then you can have one on top of the other. So you can make the line histograms. And this is helpful when you have like a ton of histograms that you need to start comparing. Okay. And again, we're not going to, this is a pure demo thing because we'll do both. We can do a share axe on the histograms too, so we can make interactive widgety things. Where if I zoom on one, I zoom on the other. See? Zoom together, interact together. And the axes adjust. And if you need to reset, there is a reset button. Yeah. Okay. So, bars and pies. I am actually a strong believer in the pie chart. I know. How many of you have been taught that pie charts are the worst? Yeah, right? Yeah, pie charts are fine, right? When do we use pie charts? We use pie charts when we want to show proportions, ratios, right? I want to show the ratio of who lived to who died. It's a ratio. It's clean. Yeah, probably. So the first thing is I'm going to do a little bit of panda magic again. I'm going to get my counts. 180 survived. So what's my ratio of survived to died in this data set? 2 to 1. So Pi can do a lot of things. I can make the most Excel-tastic 3D exploded pie chart in Matplotlib. We're not going to do that. We're going to make a very simple pie chart here. We're going to make the values because we have the values. We're going to get them out of pandas using dot values. We're going to label it because, again, a lot of our methods, we can pass in labels. So it'll take care of that aesthetic for us. Right? Again, anything that's on the chart itself, anything that has as an aesthetic that has to do with the chart itself is passed in as a parameter to the chart. Anything that is an aesthetic on the grid or on the axis is an axis object. So here we're going to pass in the colors and we're going to pass in the labels. And I have a pie chart. And again, I'm going to skip this. Bar chart, again, we're going to grab the counts, men, women. The reason I'm doing men, women here specifically is to show you a use of the categoricals. Otherwise, we would just, I don't know, anything else. So we have, right, we have men, we have women, we have the count. So pclass.index and pclass.values. The index is what we're counting, the values is what the counts. What goes on the X for a bar chart? What goes on the X? The value on the X. The index. The thing we're labeling goes on the X. What goes on the Y? Count. Exactly. So we're going to plot, and we're going to pass in the index and the values. And it'll make our plot. And it'll be labeled. Because here, the thing we're actually plotting is that male-female. Like, we don't need to do the remapping. I will say this only works if you don't need, like, fanciness. If you need fanciness, then we have to go into the formatters, and it becomes a thing. Okay? And now Tom's going to tell you about images. Do you want to take 2? Or you're good?
Oh.
Oh.
Okay. and something Hannah didn't mention is the support for string categoricals was her Google Summer of Code project from 3 years ago? 2 years ago? 3 years ago. So if you appreciate that, you should thank Hannah. All right. So, I think I'll do this. Well, that's not good at all. Apparently. So I will just do the scrolling through notebook. Where's Control plus? Your keyboard's wrong. All right. So far we've been working with essentially 1D data or series of 1D data. Sometimes you also have to deal with arrays of 2 or higher dimensions, where you've got 2 dependent variables, 2 independent variables, and a dependent variable in the array. So our sample data set for this is going to be some elevation data pulled from a base map tutorial. And base map is one of the mapping libraries built on top of Matplotlib. And if we just look at what's in here, it's a NumPy array. It's about 300 by 300, and it's floats. So, yeah. Oh, I did not. That's bad. Stop. That's better. Yeah. Yes.
You're good.
Can you read that in the back?
Maybe one more.
One more.
Also, you disappeared it, but there's a magnifying glass that will just pop the code.
These are also your slides. These are notebook board. So if you want to follow them in your notebooks,
Okay. So the simplest way to get 2D data onto your screen is IMShow, which just takes your image, color maps it as we discussed before, and puts it in the axis. But when you have this data, like from these colors, we know nothing about what these values actually are, what they mean, any of that. So we want to be able to label that, and we have rich support for color bars. So now we've taken a step up the hierarchy of objects here. Currently, we've always been working with axis methods, right? So you're doing ax.plot, ax.histogram, ax.scatter to add artists to the axis. Now when we want to add a color bar, the color bar is its own axis, so it's a figure method because the figure owns all the axes to add that. And what we pass to the color bar is the artist that we want it to be associated with. So if you've got multiple things that are color mapped, you can have a color bar per thing you're color mapping.
Sorry, what is an artist?
Oh boy, I went down a can of worms Hannah's been carefully avoiding. So everything in Matplotlib, like artists are what we call objects in Matplotlib. So everything you see on the screen that like makes a mark on the final canvas is represented internally by an artist. And then when we draw, we walk a tree of these things to consecutively render them to the screen. Is that okay? Basically, the things that are returned by the axis methods are artists of some subclass or another. We read the elevation from a data file that should be in the repository. So by default, when we do the color mapping, we use the full scale of your data for the mapping. Sometimes you may want to clip either the top or the bottom because for some reason values below a certain value don't matter, or you've got some outliers that you want to clip. I work in imaging and frequently look at like a hot pixel that's, an order of magnitude bigger than the rest of our data. And if you just throw it into the defaults, you see one very bright pixel and the rest of it is whatever your lowest value is. So the vmin parameter, it will set the minimum of the colors of the color mapping. And I guess we'll take a 3-minute break for you to try to actually. Do you want to take breaks on, or do you want to just keep rolling through this?
How are you all feeling?
Keep going. Just go. Okay. So the symmetric thing to vmin. Oh, the keyboard is wrong. Oh goodness. So if we set a Vmax, we can clip it from the top. So if you need to, if you're really only interested in a narrow band of your data, you can get that. So the color maps Matplotlib uses, one of the big changes we did in Matplotlib 2 about 2 years ago, feels, I don't know, was we changed from the defaulting to Jet to defaulting to Viridis, which is that beautiful green color map we've been looking at.
Basically, Matplotlib between version 2 and version 3 changed how everything looks.
1 and 2. It was between version 1 and version 2. We changed all of the default styles. There's some domain-specific reasons you might not want to use this screen. So I linked to CM Ocean here, which is a project by Kristen Thing, to develop a set of color maps tuned to oceanography that have like semantic meanings, for the data they're looking at. And if you're looking at 15 heat maps that are all of different ocean parameters, by using consistent and different colors for each of those parameters, that helps make that more readable. Or you might just hate green. As we saw with scatter, the IAM_show takes the same CMAP argument, of which I guess as we already show, we ship with probably 20 color maps built in, and you can register your own. If you need a color map friendly linear perceptive, a colorblind friendly linear color map, we now ship Cividus. Inferno, which is just Inferno, Magma, and Plasma. Were the other candidates to be the default color map in 2? We only went with Viridis. And for the MATLAB fans in the room, if you must, but please don't. And again, the IAM_show takes in any color map, so we could also do silly things like tab 20. And it's no longer a sequential color map, but you at least get something cool looking. In addition to, when you're working with array data, in addition to just showing this as an image, sometimes you might also want to compute contours. And we have support for that. Which again, if we're just running through this, so this.
Automatically picking the levels at which the contour.
Yeah, so there again, there's a lot of things, like whenever there's a choice of like bins or levels, we've got some default, and you can always override them. So I think if we do levels, just to pick something silly, you can go down to 2, and I think this is the number of gaps, not the number of lines. So we have 3 contour lines here, or we can go up to. Which basically reproduces it. Yeah. And you can also pass in you can also pass in explicitly pass in where you want the bands to begin and end.
label those contours? You can, but I can't do that off the top of my head. Yeah, I can't do that off the top of my head, sorry. There's also a contour F, which will do filled contours. And I'm going to set this back to whatever our defaults are. And I think there's support for labeling the contours. I think in a legend, and also in inline, you can put like 200 on the contour line itself. Right. So earlier Hannah mentioned this pipeline where we take, when you provide your data, we need to somehow get that to an RGB color on the screen. And we do that mapping in 2 steps. The first of which is we map your data from whatever scale you provide to the range 0 to 1. And then we have a set of color maps that go from that 0 to 1 to the RGB values. And by separating this, we can independently control what the mapping is and what the colors are. And so far, the default is linear. So whatever the Vmin and Vmax are, you linearly interpolate your data values to 0 to 1 between those two. But sometimes that's not enough. Like, with the scatter, Hannah showed us a discrete color map where you don't have a continuous thing to map. So we're just doing lookup. And if you have data that has orders of magnitude different values, you need an appropriate scale for that is log, and we can get that through the log norm. And to get ourselves some realistic data which has wildly different amplitudes, we just take the Fourier transform of this elevation data we've been working with. And you can see this is the same data, just plotted with different scales. On the left, we have, there's basically the constant is the highest, the constant is the highest value, and everything else is just washed out at 0, as near as we can see. And when we look at the log, you can see all the speckle patterns, which says there's not really anything periodic in our image, but we probably could have guessed that. And if you note, the color bar also adapts itself to be log based on what the norm is and the color map is. And another, I'm going real fast. And another extremely useful normalization is that sometimes you just want to basically bin your color data. Basically get something like I did up here, but just on with just even spacing. But you want to be able to control the bins based on something that So if this were in the case of elevation data, you might want to say like from here below is ocean, from here to here is temperate, from here to here is above the tree line, whatever coloring makes sense to you. You can specify a boundary norm where you explicitly give it where the edges are, and then it remaps everything in that bin in that range to the same value. Come on. So in this case, we're just using a 1D array of 0 to 20. And if we use a 20 length color map, you just get the color map reproduced. But if you use the boundary norm, you can control the binning. And that is the end of this notebook. Does anyone have questions? Should we go on to the...
Is there a reference book for Matplotlib? There's one for ggplot. Is there something like that for...
So,
Closest is probably Benjamin Root's Anatomy of Matplotlib.
Benjamin Root has a book, the title I should have off the top of my head, which I don't. I think we linked to it in the docs, where he goes through building an interactive web app or interactive weather application, in making use of all this machinery, and the docs probably.
Yeah, the docs are super comprehensive. Like it's all in there. It's fine.
But yeah, in terms of
starting path. I don't think we have a, I mean, Ben's book is the best for that. So, okay, so we go to 12:30? When? We go to 12.
So,
So in the last 15 minutes,
well, remember how we said we would leave you all the time to ask us all your very specific plotting questions? Yeah, I mean, otherwise what we'll do is he built up a whole bunch of interactive stuff so we can show you, and we can show you like all of the libraries built on top of Matplotlib to do all the things. Your choice. First more. Your choices are, you can like ask us questions about like, how do I do, or what are the references for like the specific things I need to do. Tom can show you kind of all of these. These are the other 4 or 5 notebooks is the like interactive stuff. We can also show you the different, like there are a whole bunch of libraries built on top of Matplotlib, like, cause it's like, where do you go from here? It's not just that you use core Matplotlib, it's that once you understand how the axis works and how the parameterization works, all of these libraries built on top of Matplotlib, they work the same way. So you can not only do an image in Matplotlib, you can now do a Seaborn image, a PyPlot image, a
pandas,
X-array, CardOP. There is a page on Matplotlib called third-party packages that has all the things. So I was saying, like, your shirt, the ridge plot, is a ridge plot library, ridge map library.
the author of which is here at the conference, if you find
Yeah.
Colin.
Yeah, Colin Carroll makes like lots of really cool stuff with that. So if you need geo stuff, basemap and CardOP are your deal. Oh, and geoplot, which is a brand new one that hasn't been added yet. And PySal, they're all built on top of Matplotlib. Ridgemap, if you like the ggplot, there's a ggplot kind of thing built on top.
There's several.
And there's a hell of a plotline, yep. All your declarative, alter, no, but kind of. If you're doing broken time series stuff, you can do, so if you're doing like categorical stuff, large data sets, we have the scatter density. If you're doing Seaborn, if you're doing the data science people in the room, Seaborn will be your friend. It does all the statistics plots really easily, really cleanly, and lets you style, and like their default styles are pretty nice. AstroPy has a bunch of stuff for astronomy data. Yellowbrick, if you're machine learning, they try to visualize the entire pipeline for you. All these interactive helpers, and I can't find it, but Upset is my favorite because it's like Venn diagram visualizer. If you have like extended categorical set stuff you need to find. So the idea is like there's this whole ecosystem. Matplotlib is building blocks where the Legos, but now you have all the play sets.
I'm back, okay. Okay. So, right. So mostly we've been working with the inline backend. If you remember at the beginning, Hannah mentioned we have many backends. And actually this is related to the artist question, and that the way Matplotlib is architectured is there's our in-memory representation of what the figure is, which is the whole artist tree. And then when we want to produce output, we hand that to a backend that renders it. And the inline backend renders it to PNG, encodes that as a byte64 or base64 string, and shoves it in the notebook, which is great because it shows up, and when you save, it's persistent, and it just works everywhere, and it's fully static, and it's great. If you're on the desktop, we have bindings for GTK, Qt, WX, TK, and the native Mac windowing system that basically pop up a GUI window and then shove a ping in it. And in the notebook, we have the notebook backend, NBAG, or notebook backend, which ships with Matplotlib, but only works in classic notebook. And then there's IPyMPL, which is a third-party package that works with JupyterLab. to separate package because Jupyter Lab moves much faster than we do. And if we try, having a separate package means it can release at a cycle that keeps up with Jupyter Lab. And in those interactive ones, in addition to showing you the figure, we also capture all the user input. So if the user clicks on your figure, we capture that and offer you a callback to do something about that. So I'm going to skip over all of this text that you can read at home later and show you the pretty things. I'm just going to skip that one. So this is a figure that as I'm clicking, we're adding points interactively to the line. So like if you need to capture input from your users, like, the computer can't find this circle, this kind of wiggly circle, but you can. Please give me a hint where it is. This is the sort of thing that you can build up. And to scroll back up to the code, this is the code that implements that interaction. Well, I guess that, right? You need to register a callback, which is this much, and then the callback itself. And I guess a personal note, this is what made my PhD finish, is being able to capture lines on images that I could see that the computer couldn't. And I guess if you look at if you look at the printout, if I right click or middle click, you can see I'm just printing out the interaction we're getting in. So you can capture left mouse, right mouse. We capture scroll events. We can capture all the keyboard keys. If you hold down Shift and click, we know we're holding down Shift. So now you can start implementing all of the, the rich user interaction where you say, well, if I click, add a point. If I shift click, remove the nearest point. And so you can really have a rich user interface with relatively little code. And because we're working with Matplotlib's event system here rather than the native UI's event system, this code is now transportable across the notebook and the desktop backends. So if it works here, it will work in Qt on your desktop. So if I lost everybody, that was very fast. Any questions? Because in the last 5 minutes, I've got one more. Well, I got two more that I can just blow through, or we can take questions. Oh. All right, I will blow through one more, and then.
Also, we don't have an example of this, but you can do really simple animations in Matplotlib, and you can then render them to JavaScript, so people can still click through. Could you explain the add property a little bit?
So this is a Python thing. This isn't a Matplotlib thing. And basically, if you decorate a function as a property, it becomes a zero parameter accessor. So when down here, if I do linemaker.curve, it goes into it runs that function and returns me the value. So this is very handy for like derived attributes. And to add read-only attributes to Python if you want that. Is that at least there's probably a half an hour of unpacking what's going on there. So in the last one, I'm going to jump to the.
Okay, could you explain that percent run and like?
Yeah. So the percent is a Jupyter thing, which is they call it the magics, and they're a way to say Their way to say the code I'm about to type is not actually Python, do something special with it. And when you do %matplotlib, the backend name, that tells IPython to do all the machinery in the background has to do to set it up so that the interactivity integrates correctly. And the second one, %run, takes whatever's in that file and runs it as if you typed into the cell. And that's, what's in that file is maybe 70 lines of code that is needed to make the prints from the callback show up in the notebook. Then that's a Jupyter detail about how the prints get, like how standard out from the kernels gets routed.
So is it like a command line thing?
It's a Jupyter thing. So it'll work in the notebook, it'll work in IPython. This will not run in plain Python. Does that help at all? Oh, this is not gonna control minus. Okay. So I'll glossing over all the details. One of the standard data science data sets is like the horsepower, displacement, acceleration, miles per gallon of a bunch of cars from the 70s. And what we have at the top is a elaborate bubble scatter plot, which is showing the model year horizontally, the acceleration on the Y, colored by the horsepower and sized by the displacement. And at the bottom, we have a histogram of the miles per gallon. And if I select a region on here, it will mark the points that are in that selection window. We don't have time to go through this, but just zoomed out, this is all the code required to implement that. It's not trivial, but it's also not, a book's worth. So, right.
So what we want from y'all, if you please be so helpful, is this tutorial, the goal is to run it again. So what we'd really love from you is, you have your sticky notes. Can you write on there things that worked and things that didn't? Can be 1, can be 2, just like whatever you think would be helpful for us to know in terms of revising this and improving this tutorial. Thank you.